Welcome to the third day of solving quadratic word problems. So we've looked at a couple different types of word problems where we had to solve for the answer, and then the next day we had to switch to the vertex form in order to find the vertex so we can find the max and min values. So today we're going to be I'm just going to throw different questions at you, and you have to be able to identify what it is that they want you to find, and then kind of pick an action plan that you can use in order to get to the answer. So again, in general, when you're going through these problems, if you see that they want you to find the max area or the max height or the minimum profit or minimum costs, etc., like if they're trying to get you to find the highest or lowest, smallest, largest, maximum, minimum values, you know that the action plan that you need is that you have to go find the vertex, because again, we're looking at quadratics, and the max, right? So it's found right there, right? And the min, if you have to find the minimum value, is found right there. And those two spots, they're the vertex of the quadratic formula. So if you can get to the like if you have it in standard form and you get it to this form, the vertex form, then you can find information about the max and min. So just watch out for that. And then if you don't see max or min, then you kind of use these other ways to solve the problem. So some typical ones that we have seen are, I'll give you the equation and I'll say x is equal to 6. So all we did was, we plug it in and then we calculate it. So I'll just show you this one here really quick. We have to go find the y value. We're just going to plug this x that we know. So I plugged it in here, subbed it in. Okay, and then I just use BEDMAS, calculate it out, and then I have my y value, and then I get to my answer. Okay, so there are a lot of questions like that where I'll say, at 5 seconds, what was the height of the ball? And at 2 meters across the field, what was the height of the ball at like 2 meters, okay, from where it took off. So again, that y value is like the height, the cost, just the results that we have to find, okay? But we do have the opposite scenario where, what if I give you the height of the ball? Okay, so what if I tell you the height of the ball is about here? So how many seconds has passed if the height of the ball is there? So that's when you have that scenario. So I'll show you here. So we know y, so I plugged it in here into the equation. And then from there, you have to find x, right? So it's a little tricky here to find x when there's a couple of them and so forth. So that's why what we'll do is we'll move this 6 over here, make it equal to 0, and then right now it's positive 6, so when it goes over there, it'd be subtracting 6. If I subtract 6 from the 5 there, I'll get -1, okay? All right, so then I have a quadratic equation here equal to 0, and from here I need to find the x's, okay? So in order to do that, I'm going to use factoring or the quadratic formula. So again, if I can factor it really quickly, then like if it actually works, then it's a good method to use because it's faster, okay? Otherwise, you can quadratic formula everything if you wanted to, because this formula will find the factors of everything. So so just know that that's the plan here. So again, if it's max min, use the vertex form. If I give you the x value, you need to find y. All you're doing is plugging it in and then just finding it. But if it's the opposite, where I give you y, and now you got to find x, that's when you got to kick in the factoring or the quadratic formula methods, okay? All right, and I guess the last one just to watch out for is dimensions. I might say find the dimensions, but again, these ones, it can depend on which method to use. So again, if you see max min somewhere in the problem along with, go and find the dimensions, then you got to use vertex form. If you don't see max min, then you have to use maybe the factor quadratic formula form here. Okay, so just kind of analyze the problem, see what's going on, and then, just pick an action plan from there. Okay, so that's what you do when you have an equation. So the hard part's already done, so then you just have to kind of figure out what to do with the equation. But if you don't have an equation, though, yes, you have to build it. So just kind of go through the problem, figure out everything that's given to you, read it twice, double check it, and then draw a diagram. I didn't emphasize this enough in the other videos where always draw it, visualize it. If you know where the y-intercept is, draw that out. If you know which way it opens, up or down, okay, you should be able to make a rough sketch of what you're analyzing. From there, when you are going to go and build equations, make sure you write your variable statement. So if you're going to use letters like X and Y or A and B, just make sure you tell me what they stand for, okay? All right, and then build your equation. So you've learned 3 different types of equations now for quadratic: standard form, vertex form, factored form. So just, again, whatever is easiest to build it. And then you can convert to the other forms depending on what the question wants you to do. Okay, so once you build your equation, determine your action plan here. So again, figure out, does it want max min? Okay, get to the vertex form. Does it just want you to find y? Great, then just sub it in. Does it want you to find x? Okay, well then use factoring or quadratic formula. And again, if you, little clues like for this one we have to find x, I might say find the break even, okay, value, or find the time when the ball's at this height, or what's the horizontal distance when the plane flew this far across the sky, or this high in the sky, and so forth. Okay. Okay, and then once you're done, remember 2 answers will pop out, and so just always check to see if they make sense. So remember, negative time doesn't make sense, so you would eliminate that negative time and then just keep the other one that's positive. Other things where, I don't know, if you had to find 2 numbers, you can have a negative number, right? So you should keep both. So just kind of decide with what the problem is talking about if both answers do make sense. Okay. All right, and then once you're done, you can make sure you make a therefore statement, and make sure you write the keywords. Don't just write the answer is this. Okay. Actually write the distance. The horizontal distance was something meters. Okay, so write the units as well. We're going to spend another day just going through more quadratic problems, but now they're all mixed up, so you just have to kind of read through carefully and make a decision on what action plan you're going to use in order to get to the answer. Okay. All right, so make sure use the graphs method too. I think that's working for a lot of you, just to kind of organize your thoughts, and it's something good that you can apply it to the sciences as well. All right, so we have a ball. It's thrown straight up. Okay, or no, sorry, straight down from a 180-meter cliff. Okay, here's the equation that models the fall of the ball, and h is height, t is time. So let's get a diagram drawn here. Okay, so again, try to look at it and see if you have information like, do you know the y-intercept and so forth. Okay, so again, we know that we threw it from 180-meter distance, and on top of it in the equation, the constant term here for the standard form is 180. So we know that y-intercept, okay, or h-intercept, I guess, is 180. So we know the ball went from there and then it just dropped down, okay? All right, so it says straight down, but I think it took, like if we magnified it, it took still a quadratic shape form here for the fall. Okay, so we know that's 180 meters. We know this is the equation, so this is our given information. And then, h is the height, t is the time, okay? All right, so what we need to find here is how high is the ball after 3 seconds. So again, you're going to look through here and just make a rough sketch on your diagram. So okay, so yeah, there's 3 seconds there. We need to figure out the height. Okay, so that's what's required. Okay, we know the information time is 3 seconds. So can we find the height? So again, this is an example of where you are given x, okay, and you just need to go and find y. So you're just plugging it in. It's just a substitution type question. Okay, so let's go and do that. So you can just write that. It's just substitution, sub in value. Okay, all right, so let's write the value or the equation out first. Okay, so there it is, and we know that t is equal to 3. So let's plug it in here. So I'm going to put a 3 here and a 3 here. Okay, we're going to write the rest of it now. So 5 times 3 squared, subtract 5 times 3, plus 180, like that. Okay, so we subbed in 3 where all the t's are. Okay, and then we're going to follow BEDMAS here in order to calculate out the value. All right, so we get to 120, and we're looking at meters here. Okay, so part A, how high is the ball after 3 seconds? Therefore, the ball is 120 meters, okay, after 3 seconds. Okay, so again, we threw the ball off, and at 3 seconds, it's 120 meters in the air still. Okay, so that one's done. So again, that was just a sub in the value in order to get to the answer. All right, part B, how long does it take for the ball to reach a ledge 80 meters from the base of the cliff? Okay, so again, let's draw this out so we can visualize it. Okay, so we have we want to know how long it takes for the ball to fall when it reaches a ledge of that's 80 meters from the bottom. Okay, so from 80 meters up, so right here, okay, sorry, the diagram's kind of messy, but yeah, how much time is that now? Okay, that has passed. So we need to go find t. So again, we are looking at, we're given the y value, so we're going to plug it in, and then we're going to end up with a bunch of x's here that we have to solve for, and that's when we're going to use the factoring or quadratic formula method in order to get to the answers, okay? All right, so let's plug it in. Okay, so there's the 80 that goes in for the h, and then the rest of the values here in terms. Okay, so in order to solve this, we need to have this expression equal to 0, so we're going to move the 80 here. That leaves a 0 behind. Okay, when this 80 moves, it becomes subtract 80. Okay, and then you end up with an expression that looks like that. Okay, all right, so from here, then I know I have to find t, I have to solve for t, so in order to do that, when you have a couple t's like that and a quadratic relation here, you're just going to go through and try to do the factoring. Okay, but that all starts off with finding the greatest common factor. Okay, so one thing I want to show you here, so when this greatest common factor goes out, so again, we're not using complete the square method, we're just factoring here. So this way you don't have to keep writing these square brackets and so forth. I just want to show you, I can take this 5 and divide it away. So when I do that, I'm moving it over into the 0 here and dividing it away. So when I do that, I don't have to write those square brackets anymore because there's nothing in front here. So when I do that, this becomes a 0. So whenever you factor something out, when you're trying to factor, like the greatest common factor, and then it's equal to 0, you can divide it away and get rid of it. So you don't have to keep writing it all the way down the page, because in the end, this a value, this greatest common factor that's out here, doesn't affect the zeros or the roots or the x-intercepts, okay? All right, so now that we have it here, this is a simple trinomial, so we're going to try to factor this. So the middle term is 1. The outside terms multiply and make negative 20. So we're trying to think of two numbers that will multiply to 20 but add to 1. Okay, so again, this is what we've done in the past, but I thought of the two numbers right away, 4 and 5. Hopefully you did as well. So again, we need to multiply to negative 20, so one of them has to be negative, but we have to add to positive 1. So since positive, the bigger number has to be positive, and the smaller number has to be negative. Okay, makes negative 20, adds to make positive 1. Good. All right, so then from there, because it's a simple trinomial, we can just write the expression like that so we don't have to do decomposition, okay? All right, so -4 plus 5, good. Okay, so now we're at the end. We're trying to find t now, so all we do is solve for t. So we're going to pop out the opposite here. So this is -4, so t is +4, and in here t is -5. Okay? All right, so now we're looking and going, all right, what did we have to find? And we needed to find how long it would take for the ball to get to 80 meters, okay, from the bottom of the cliff. So this doesn't make sense, a time of -5. So if you were to look at this diagram here and extend it out, it would be right there. But since we threw it from the cliff, right, and then down, this is -5 seconds. Doesn't make sense. We can't have negative time. So right here, oops, I guess it would be right here, sorry. When we extend it out, that would be -5 there, okay? And then here, when we get to here, that's 4. And that's the one that makes sense that we're going to use here. Okay, all right, so this one's not a solution. Okay, so we're just going to not use it in our therefore statement, but the other one is, okay? All right, so I don't know, we were given this stuff, we had to find, our required was that we had to find t. Our action plan was just to sub it in, right? Sub in, value, and solve, right? I should have written those down. All right, this is our plan in motion here, calculating stuff out, finally got to our answer, now we're making our therefore statement. Okay, so we needed to find the time it would take. So therefore, it took, okay, took the ball 4 seconds to drop to 80 meters, right? And there you go. Okay, so there, this was a nice question. It had both, where we sub in the, the x value, which was t, and then we just had to calculate out h. And then we had to do it the other way, where if I gave you the height, can you go find the time? And then we had to kick in factoring in order to get to our answer. Again, if you use quadratic formula here, you would have gotten to the same answer as well, but just it would have been a little bit more work, okay? All right, so now let's try the next one. Okay, so again, today these should be familiar. It's more just about, can you select the right method, okay? All right, example 2, we have volunteers at a food bank, and they're arranging a concert to raise money. P is the profits, N will be the number of tickets, okay? So this equation here represents the profit versus the number of tickets sold. So again, we can make a diagram here. So it's a quadratic because it's squared. And then see how the, profit here is negative, so make it negative here. Okay, so then it goes up because it opens down because of the negative sign here like that. Okay, so this is what we're looking at. We're looking at profit and the number of tickets sold, okay? So again, remember profit is what you get after you take how much money you made and subtract the cost. So it would have cost, if they're arranging a concert, so maybe it would have cost money to rent the venue to have the concert. Maybe, they had to pay money to the musicians for them to play and so forth, okay? So, but then we're going to get people to buy tickets for this concert, so we'll make some money as well, so in revenue. So we're looking at, so remember profit is the revenue, okay, subtract the cost, okay? So whatever, again, if it's positive, okay, that means you're making money. If it's negative, like down here, so you can think of this as like you started $48,000 in the hole, okay, so that's what it cost for this extravagant concert, obviously. So we need to make that money back in selling tickets, and as we do, we'll make more and more money here. Okay, so now that we've kind of analyzed what we have here, part A wants you to calculate the number of tickets that they must sell to break even. Okay, so there's that word break even. So where is break even on a picture like this? It is right here. Okay, this is where you break even. Okay, so those are the x-intercepts, right? So, or the n-intercepts. So if you have to go and find those, so you need to figure out the number of tickets that will help it break even. So you need to find these two values right here. Okay. All right, so you know you have your expressions. So again, if it's break even, you are going to factor or use the quadratic formula, okay, QF. All right, so let's go through and, okay, so we need to figure out the n value for when we break even. So let's put our plan in action. So we need to use factoring or the quadratic formula. Okay, so let's put our plan into action here. So take the equation. Okay, so there's our equation here. So what's important about breaking even right here? So that means your how much money you made and how much you ended up spending is even. Okay, that's what they call breaking even. So so that means that you don't owe any money, you don't have any money. So your profit right at that spot right there is zero. So that makes sense, right? Because that's where zero is on the graph. So we know the profit is zero. So we're going to plug that in, and then we're going to go through and figure out n. Okay, so in order to figure out n, we need to factor or use the quadratic formula here. So I know I told you, try to use factoring first because it's a little less work. But sometimes factoring could be more work because you're looking at a really large number here for C. And like I know we'll take out the negative and so forth, but it's still a really large number, and that's going to be a little bit of a headache to think of all the factors that can multiply to make 48,000, but then they add to make 580. Okay, so sometimes when it is a little bit of a headache to do it, use factoring, go ahead and just use the quadratic formula. Okay, because we know that works. It's probably going to be about the same amount of work. Okay. So if I go ahead and do that, I'm going to find my A, which is -1, my B is 580, and the C is the negative 48,000, okay? All right, so let's just go through and, yeah, let's just use the quadratic formula here. Okay, so I'm not trying to find x right now, I'm trying to find n, so I'm just going to call it n equals the quadratic formula. So negative b plus or minus b squared 4ac, and then 2 times a here. Okay, so negative b is negative 580 plus or minus 580 squared 4 times a times c all over 2a, 2 times -1. Okay, so from here, just kind of go through and hack your way through and then check your answer. Okay, so I went ahead here and plugged everything in and, carefully calculated everything out. And then I got to, this large number and set the square root. But when I went to square root it, it actually came out really nice. So that means that you could have used the factoring method. Something would have worked. But yes, it would have taken a while to list all the factors and eventually get to what you needed, okay? So anyway, but that's why sometimes quadratic formula is just as good to try because I know there's a lot of work here and so forth, but sometimes factoring can be onerous if the numbers are really big. Okay, so we went through again, so I got it as simplified as I could, and then from here I separated, remember, because there's two answers, there's a plus and a minus. So here's the plus, here's the subtract here, cleaned it up, and then we get to these two results, okay? So again, if we're looking back at this diagram, these are the two spots here, so 100 and 480. These are the two spots where your profit will be zero. Okay, so if you think of it as this is the number of tickets sold here. So yeah, you're as you increase number of tickets that you sell, you end up with more profit. But at some point, you don't make as much profit as you keep selling more tickets because maybe there's other things involved here with the costs, such as like the more people you invite, then there's we have to hire more servers or charge you more for cleaning or whatever it is. So anyway, so this is just this expression models the profit, but yeah, we don't know exactly all the stuff that's going on here and so forth. Okay, but either way, so we will go up. So at some point, when you sell 100 tickets, you will break even. Okay, make lots of money. Okay, the money starts to drop, but you're still making money. But then at some point, you will max out on how many tickets, I guess, that you can sell. And if you sell more than that, it's just you're not going to make a profit. Okay, and the whole point is to make a profit so we can raise money for the food bank here. Okay. All right, so this is part A, calculate the number of tickets to break even. So then we say, therefore, in order to break even, you need to sell 100 or 480 tickets. So we're going to continue with example 2 here. So we figured out how many tickets we need to sell to break even. Okay, so here's part B. We need to determine the number of tickets that must be sold in order to maximize the profit. Here's a diagram of what we're looking at here. So again, here's the profit versus the number of tickets sold graph. So again, we need to figure out the number of tickets that in order to maximize the profits here. Okay, so there's various factors involved in raising money for this for the food bank here. So again, if we sell too many tickets, then the cost of the concert will, I guess, there'll be extra costs and so forth. So that way, it'll actually drag down our profit. Okay, so there is a happy number here of tickets that you can sell in order to get to the max profit. So here, so if you take a look here, that's where your max profit is. Okay, and so we need to figure out how many tickets then do we need to sell in order to reach that maximum point. Okay, because if we start selling more than that, then the profit starts to go down. Okay, so there's the required. We need to find the X value here. Okay, so what you're going to do here is because you, again, are always analyzing, so even though for A was a certain way of solving it, B can be different, and so you need to make sure that you're still paying attention to what you need to do. Okay, so again, I see the word maximize, so whenever you see that, you want the max profit and so forth, you know that you need to use the vertex form. You need to get to the vertex form. Okay, and when you get there, you can find the vertex values in order to get to the information that you need here. Okay, so we don't have the vertex form right now. We have the standard form. So what do we need to do in order to get to the vertex form? We need to complete the square. Okay, so again, you can use the box method, the area model, or you can use just kind of finding, the middle number, dividing it by 2, etc., doing all that stuff. Okay, but we don't want this negative in front either, so we're going to divide that negative out, everybody. Okay, and then remember how whenever we took a number out before, I said you can get rid of it? You could do that before because it was equal to 0, but here we're not going to get rid of this negative 1. We're just going to leave it out there temporarily. Okay, so here are the numbers. So we have the negative 1 divided out. So these are negative, that one's positive, and so forth. Okay, so don't, just because it looks like this, don't start factoring. Remember, we're trying to complete the square. So we're going to take the first 2, right, and find the third term that will make it a perfect square. So again, B is the middle term, negative 580. So if we divide that in by 2, you will get negative 290, and then we're going to take that number and square it. Okay, and you get 84,100. Okay, so now that we found the third term, we're going to add it in here. Oops, do it in red here like we did before. So we're going to add the third term, but to keep the balance, we're going to write its opposite in. Okay, and then add that last term that was already there. Okay, so now remember this first part, 3 terms here, that's the perfect square. So we're going to factor it down. Okay, so all I do is I look at that b over 2 term. It's always right here. Okay, factor it down, and that's what it looks like. And then I'll add these 2 up. Okay, and then the last step is to multiply this -1 in here and there. Okay, so that becomes negative in front, and here that negative makes a positive. Okay, so now we have it in vertex form. Okay, and again, we need to do that because we're trying to find the max profit. So again, even though we have an equation that looks like this and an equation that looks like that, if we graph them both, they would have the same shape. They would be the exact same graph. But when we have it in vertex form, we can actually find the value of the vertex. Okay, so let's actually pop that out. So the vertex here is positive 290 and 36,100. Okay, so again, what are these? This is the max profit. Okay, and then this here is the number of tickets. Okay, in order to get to the max. All right, so they wanted to know, determine the number of tickets that you must sell in order to maximize the profit. So this is it here. Okay, so therefore, so you need to sell 290 tickets to maximize profits. Okay, so that example showed us how to solve your way to the answer using factoring or quadratic formula. B showed us how to deal with it when it's a max min, so we need to change it to the vertex form. Okay, so there are a couple different strategies here, but you need to use a specific one for each of those problems. Okay, so it's about recognizing what you need to do. Okay, so you've seen how to solve these now for a few days. Okay, so the next one here. So I'll get to some, area and perimeter type questions now, and then there's a number one. Okay, so we just need to go through. We have some clues here. We need to, like we had the equations for these ones, so these ones don't have equations. So we just need to kind of read through, build an equation, and then pick an action plan and solve it. Okay, so we have the length of a rectangle 6 inches longer than the width. The area of the rectangle is 91 square centimeters. Find the dimensions. Okay, so let's just write down everything we have. So let's say let L be the length of the rectangle in, what is it, inches, and there W be the width, also in inches. Okay, so we'll call A the area in inches squared. And okay, so what is it that we need to find? We need to find the dimensions. Okay, so that means we need to find the length and the width. All right, so what's our plan here? So we need to build a quadratic equation first. Okay, so build your equation. Okay, and then see how there's nothing about finding the max or the minimum values. So so from there, what you're going to just be doing is you're going to be just solving it by factoring or using the quadratic formula. Okay. Whenever it says find max or min, then you're looking at using the vertex form, okay? But we don't need the vertex here. All right, so let's now go through and build some of the equations here. So we know the length is 6 inches longer than the width, okay? So I can write this as W plus 6. So length is actually equal to W plus 6, width is W, area is still area, okay? So, then from there, the area formula, so again, what's the area of a rectangle? Length times width. So we know that the area of the rectangle length times width, so we can plug in our L and W in here. So we know L is W plus 6, and width is width, like that. Okay, and then on top of it, it's telling you that the area here is 91 square inches. So there's the value there. Okay, so I'm going to also plug the A in here. So 91 equals, and I'm going to put the W first, I guess, W, and then W plus 6 after. So they're both the same. All right, so we have everything we were given. We built our equation here. Okay, and the whole point when you see these area type questions, you don't want to have, A, L, and W all out there, and you have to solve it. Okay, there's too many letters involved here. So what you have to do sometimes is, looking at the information given, you can actually replace one of the letters so that you're using the other variable. Okay, so width is W, so I'm going to write W plus 6 equals the length, because it says the length is 6 inches longer than its width. So L equals W plus 6. Okay, and then area, we know it, so we're plugging it in, and then we have this expression here. Okay, so we have to find the length and the width. So since we only have W here, we're going to go and find W first, and then we can figure out the length after. Okay, all right, so if we go through and calculate this out, okay, I get to here. And again, if I'm going to go and find the answers for W, I have to equal it all to 0. So let's move the 91 this way. Okay, and there it is. And then use a factoring or quadratic formula to solve it. Okay, so yeah, if you're like looking at the 91 already and going, oh, I don't know what values work for that, you could just kick in the quadratic formula if you wanted to, or you can give it a try and see what numbers will work for 91. Okay, so we have to multiply to 91, negative 91, and we have to add to 6. Okay, so 1 and 91, nope. 2 doesn't work. 3, 4, 5, 7 works. Okay, and if I tweak these, we can get 6. So we just need to figure out. It has to be negative, but this one has to be positive. So the bigger one will be positive. The second other one will be negative, and that will add to positive 6. Okay, so since this is a simple trinomial, you can factor it really quick. There they are, okay, and then kick out the answers. All right, so now you've solved it, but what are we trying to find here? We need to find the dimensions of the rectangle, okay? So in this case, W is width. Does it make sense to have a negative width? No, okay, so this one's not a solution. Okay, so we have width. So what was the formula for length? Well, length was W plus 6. So since length is W plus 6 like that, and we know W is 7, the length is 13. Okay, and this is all in inches. Inches. Okay, so let's report our final answer here. So therefore, the dimensions for the rectangle are 7 inches and 13 inches. Okay, and you'll see some problems or books write it as 7 inches like this by 13 inches. Okay, because that's how they write dimensions, length by with an X. So by, they say by 7 inches by 13 inches. Okay, so yeah, there was another factoring type question. Okay, but again, we had to build this one from scratch. We had to set the variables. Okay, we had to take our information like we know the area formula for a rectangle. Yep, we actually know the area. Okay, so just jot everything down that you know and then go, okay, so this is what I have to find. So again, always use the grasp method to organize your thoughts, okay? So our plan is, okay, we have to build our equation, and then because we have to find the answers, and it doesn't say max or min, that's how I know, okay, I gotta use quadratic formula here, okay? All right, so we went through, we built it. So we had our area. We knew our length was greater than the width by 6, so we were able to plug it in. So the nice thing about that step there is that because we knew that length was w plus 6, we could plug it in, and then it gets rid of one of the letters, so there aren't 3, and then we could solve it when we only have the 2 letters, okay? And then on top of it, we knew that the area was equal to 91, so we plugged them both in. And then we ended up with just one variable to solve for. So that was a good thing. Okay, so that's what you also want to focus on when you're building your equations. Okay, so let's move on to the next one. So I think there's, a couple more left, and then we'll go from there. Okay, so we have this one here. We have a couple numbers to find now. So integers, that means that you can have a positive or negative number. Okay, and what does the word consecutive mean? Okay, so consecutive just means one after the other, okay? So that means, if I had consecutive numbers, I could say 4, 5, 6. They're one after the other. So consecutive, that's what it means, okay? So the product of 2 consecutive integers, so integers that are one after the other, is 56. Find those integers, okay? So let's do that now. All right, so let x be, there's a couple numbers, right? So let's just call the first one first number. Okay, so if the next number, we can call it the second number. If we know that they are consecutive, so if I know one is 4, the next number, it has to be 5. So what did I do to get to 5? I added 1 to get to 5, right? And if I need the next consecutive number, I add 1 and I get to 6, right? And so forth. So if I know x, to get to my other number, I know I just have to add x by 1. Okay, so the second number can be represented by x plus 1 like that, okay? All right, so, so from there, we know some other information here, like we know that the product of the integers is 56. So again, what does product mean? What does product mean? Okay, so that means multiply, right? Multiply. All right, so we know the product is 56. Okay, all right, so let's build our expression here. So we need to find the integers. So we need to find the first number, okay, and we need to find the second number. Okay, so let's build our equation. That's our first step. And then, so again, you don't see, max min anywhere, right? So that's how you know, oh, okay, this is just a factor or quadratic formula type question. Okay, all right, so the key is figuring out the plan. All right, so let's build the equation. Hopefully building equations isn't too bad now. All right, so we know that the product, so the product means it's like I'm going to take the first number and I multiply the second number, and the product is 56. So if I take the two numbers and multiply them, I'll get 56. Well, I actually have variables for the first number and the second number, so let's just actually plug those in. And there we go. Okay, and now we have a quadratic equation here. So let's go through and expand it out. That's x squared plus x equals 56. And again, in order to, so we have our equation built now. In order to solve the problem, I can find the values of x. We need to get it to equal to 0. So move this over. Okay, so it becomes negative. Now it's equal to 0. Now we can solve it, okay? So again, if you want, you can use quadratic formula, but if you have a race with somebody, they can probably find the answers faster by just factoring it out. Okay, so we have to add to positive 1, and we have to multiply to negative 56. So again, think you can brainstorm all the numbers. I know 7 and 8 make 56, so that we could tweak them to make positive 1. So since it's positive, I know the 8 has to be positive, the 7 will be negative. Okay, and it's a simple trinomial, so I can just write the factors right away. I don't have to use decomposition. Okay, so there you are, and now we're just popping out the answers here. Oops. Okay. All right. So so now we're going to check to make sure the answers make sense and if we can use them both. What did we have to find? We had to find integers. What are integers? Integers are positive and negative numbers, right? So it's like positive and negative whole numbers. Okay, so whole numbers are like 1, 2, 3, 4, 5, 6, right? And 0 is also one. So so you're looking at numbers like that. So you shouldn't get a decimal answer, okay? Etc. In this way. All right, so yes, these are both acceptable because yes, you can have a negative integer, okay? All right, so but we have two scenarios here. We have x is equal to 7. Okay, so if x is equal to 7, that's your first number. So what's your second number then? So your second number, remember, is x plus 2, or x plus 1. Okay, so second number is x plus 1. So if second number is x plus 1, we know that we can just go 7 plus 1 is 8. Okay, so our two numbers are 7 and 8 if we take this answer. Now, what if we take the other answer? So what if the first number is negative 8? Okay, so well, the second number is x plus 1. So if I put that in, I get negative 7. Okay, so the numbers that, so now if we go back and double check the problem here, we need two numbers that will multiply, that are consecutive, one after the other. So these are one after the other. And they have to multiply to 56. So do you agree that 7 and 8 multiply to make 56? And negative 8 and negative 7 multiply to make positive 56. So yes, they both work. So you have to state them both. Okay, so find the integers. So therefore, the values 7 and 8, and also negative 8 and 7, or negative 7, will make a product of 56. Okay, all right, so yeah, so just make sure, always check to see if the two answers that come out will make sense and can work, and then make sure you yeah, write all the possible answers that are allowed in the problem, okay? Okay, here's the last one. It's challenging, but once you get it, you should be able to solve any of these ones that are thrown at you in the future, so this year or next year. So we have a scenario here where it's an area type question, area perimeter type question, okay? So we have this person that has a dog kennel, and she wants to create an area outside that the dog can run around in somewhat, or walk around in. So she is creating a fenced in area. Okay, so 1, 2, 3, 4 dogs could be in here, so they call them dog runs. And so there's a fence here on the outside here, but there isn't a fence on the wall here where the building is, because it just attaches to the building, okay? All right, so here's the scenario. She can afford 30 meters of chain link fence, okay? That's gonna go into all these spots here all together. The runs will touch the wall, but we need to figure out we want the maximum area here, okay? Because, we want those dogs to have, some space to move around in, okay? So we have a couple conditions. So we have a 30 meters of the fencing, but we want the maximum area for all the doggies here. So what dimensions does she need for each enclosure here, okay? So, and then also for the whole enclosure here. So figure out the length and the width of all the little enclosures and then the overall as well. Okay, so we need to find the dimensions. So again, let's just, set up length and width, I guess, for the dimensions. So we have meters for units. Okay, all right, and let's just get a diagram going here. So we'll just kind of a bird's eye view of the dog runs. So we have 4 of them, right? 1, 2, 3, 4. Okay. All right, so 1, 2, 3, 4 spaces here. Okay, so, and again, we don't have a fence on this end here because that's where the building is, okay? All right, so, we can call this the width, I guess, like this part here. And then we have the length here. Okay. So normally, like again, if you were looking at a rectangle, you'd always label the outsides as length and width, right? But because we also have a piece of fence here, 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 hopefully you agree that these are all the lengths as well. Okay, so perimeter. So in general, you would if you had a rectangle, you would add up all the sides. So if you had a fence that went all the way around, you would add up all the sides. So I want you to think of, we're kind of doing the same thing as perimeter here, but we're looking at 30 meters of fencing here, okay? So, so I don't know, we can call it P for perimeter, I guess. So we're the total distance of everything here. So we have, so if we're to make an equation here, so I have the width. So if I'm adding up all the pieces here, I have the width, and then I have 1, 2, 3, 4, 5 lengths. Okay, so when I, take my 30 meters of fencing here and I cut it into all these pieces and make the doggy runs, and say we used every centimeter of this chain link fencing, then so we have it looking like this. So this will equal 30. Okay, so here is the expression to show that, okay, if we have the width here and then these are the lengths. So the other condition now is the area. So we have to also, have, the amount of fencing used to be 30 and meet these conditions, but we also have to have an area, and we have to get the maximum area. So we'll look at the maximum part in a second, but for now we need to develop an area formula. So we know that these are rectangular shapes, so we're looking at the overall shape here. We need the area of a rectangle here, so length times width. So what we're going to do here is, now we have too many letters, so if we can replace, use this equation here and replace one of the letters, then we can kind of get to solving the equation. So here are a couple scenarios here. So we can solve for L, okay, or we can solve for width, okay. So we're just going to look at both here. So solve for L and solve for W. Okay. Sometimes when you go to solve the perimeter or the other formula that's going to go into the area, you're going to find one of them sometimes comes out a little messy. So if I solve this one for L, so we'll move the W, can subtract on that side. Okay, now we'll divide the 5 away. Okay, then we get to there. Okay, so we have that equaling to length. Okay, so it's a little tricky. You're going to plug it in, and then you have a fraction to deal with. Okay, so now if we look at the other one, so again, we'll take this equation, because it doesn't matter which one you solve for. But if you want to have an easier time kind of working with the values and calculating out the answer, you might want to work with something that looks a little nicer than this. So if I solve for W here, so I'll move this over. Okay, so that equals that. So see how W is really nice? There's no fractions and so forth. So then you can plug it in and work with that. Where the fractions, you're going to be carrying a fraction along all the way through, and it's going to be a little bit, it's stressful and so forth. So I would use this one here. Okay, so let's plug that in to this formula here. So W is going to be replaced by 30 subtract 5L, like that. Okay. So then from there, if I expand that out, so multiply the L into both of these, you'll get 30L equals 5L squared. Okay, so hopefully you're seeing here that we have a quadratic formula or expression here. Okay, so I'm just moving them around so that the squared is first. So that's negative and then this is positive. All of this problem solving we've been doing so far, I've drawn a diagram, I've set the variables and so forth, and I just started building the equations. So let me just kind of set out the graph steps here. So what's required here? The dimensions are required. Okay, so that's our goal. So we need to find the length, we need to find the width. Okay, and the given, we have all this information here. We need the fencing was 30. We have a condition where we have to take into account area as well. So I don't know, you could think of this as kind of like the planning step, I guess. Okay, but in the end, because we have to get to the max area here, okay, that's what we need. So you know that you have to get to the vertex form. Okay, so the tough part here was just building the equation. So yeah, once you get to here, now you have this expression here. From here, everything should be straightforward, okay? So again, just kind of look over this one a little for a bit. But whenever you have an area and perimeter type question where you have a couple conditions, this is what you always do. You build the perimeter equation first, and then you're going to plug it into the area so that there's only one letter left. Okay, so you don't have both length and width. Okay, so let's go and find the max area. So again, if your goal is to try to get it to looking like this. Okay, so again, if having an A and an L there is throwing you off, you can change it so that it's A and X if you want. Okay, I'm just going to keep it in those letters here though. So the first step here, whenever you have to get it to vertex form, is I always divide out that number that's on the X squared or the L squared here. Okay, so I'm going to divide the -5 away. And it's okay that we have the A here. Okay, so then take the -5 out and then just write what's left. And then you have that left there, okay? All right, so what you're doing here is now you're trying to make that perfect square. So again, the second term here is -6. So if I take it and divide by 2, I get -3. And if I take it and square the -3, I get 9. So my third term is 9. Okay, so if I'm going to add the 9 in, I need to also add its opposite, and there's no other term here to write in, okay? All right, so from there, you're going to take these 3, and that's your perfect square, so you're going to factor it down. Again, I always use the b over 2 to remember, oh yeah, so it factors down to looking like L minus 3, like that. Okay, so if you expand that out, you'll get this here. All right, so, and then we have this -9 by itself coming down. All right, and one more step here. Let's get this 5 multiplied back in so we don't have the square brackets. All right, so there's our vertex form. Okay, so I know this has been a long question, but again, we are trying to find the dimensions that meets all these conditions. And then, again, when we found the area formula here, length times width, there's lots of different answers that could work here, but we want the maximum, so that's why we need to find the vertex form. And when we find the vertex here, we're going to get 3 and 45. Okay, so again, if you are looking at a graph of this, you have area and you have your length. So there's all of these possible lengths that will work to make certain sized areas for the dog runs. But there's one that is a max, okay? That's going to be the maximum area, and there's a certain length that works. So we're trying to find that right now, okay? So we're trying to find the max area here, or or we're trying to find the dimensions that will give you the max area. So again, this number here is the max area. Okay, this is the length that gives you the max area. Okay, so if we go back to the question here, they wanted to know what are the dimensions. So if I even copy this, what are the dimensions that Lila needs for each run? Okay, what are the dimensions she needs for each run and the combined enclosure? Okay, so again, if we were to draw out the different dog runs here. Okay, so remember there's 1, 2, 3, 4. Okay, so these were all lengths, right? And then we have the width here. So we need to figure out the dimensions for each run. So each run here. And then we need the whole enclosure as well, okay? Okay, so if we know the length is 3, or yeah, so we know the length is 3 meters, feet, what was it? It was meters. So we know the length this way is 3. So we know the width expression back up here is that. Okay, so that's how we find width. So if we plug it in, okay, so we know the width is 15 meters. Okay, so we know that this is 15. We know just one of these sides here is 3. So, and again, there's 1, 2, 3, there's 4, right? So if we're trying to figure out just like each run here, so that's 3 by, and then we'll just take 15 and divide by 4 here. And the whole enclosure, we're just going to go 3 by 15. Okay, so 3.75. So each run is 3 by 3.75. Okay, so the dimensions. So if we're doing our therefore statement here, therefore the dimensions of each run are, so 3 meters by 3.75 meters. Okay, and the dimensions for the whole enclosure. So again, if we're looking just at the whole enclosure like that, so we have length, we have width, so we know it's 15, and this is 3. So we can say those are the dimensions of the whole enclosure, okay? Okay, so that is gonna, these dimensions here lead to the maximum area, okay, of the whole kennel, the fenced-in area, and we also can find the dimensions of each run where the dog can run around in. Okay, so that's actually pretty good, right? 3 meters by 3. So I know it doesn't actually look that big in this diagram that we're given here, but still it's pretty big if you have a small dog. Okay, all right. So again, a tough one to end with here, but just try like look over this one again, try it on your own without looking at the answers, and then try some practice ones, and you should be good to go. Okay, you'll probably see some more of these next year, so that's why it's good to kind of just start practicing them now, and yeah, you should be able to deal with them again when you see them again next year. So, so again, the main thing here today was you were taking the same questions that you had in the previous days, but you were just trying to determine what action plan that you were going to use. So again, if it was a max or min, get it to vertex form by completing the square. If you are just simply like, you know, I'm giving you the x value, go find the y, you're just plugging it in and calculating it out. So kind of more like elementary and grade 9 material here. Okay, and then, but if it's the other way around, this is the grade 10 stuff where, well, if I give you the equation and I tell you y, can you go find x? So then you got to factor and use your quadratic formula and so forth. Okay, and then today we saw dimensions of rectangles, and sometimes we needed to use factoring quadratic formula. Sometimes we had to get it to the vertex form. So again, just watch for the words max, min, largest area, smallest area. And then that's how you know you had to use vertex form. Otherwise, if it doesn't say that, then you use this method here. Okay, so that takes us to the end of the quadratics. So I know it's been tough. It's a tough week, but it was all of the stuff was left towards the end so that you can get really strong at factoring, strong at using these tools, so then you can attack these questions with all the information that you know.